All right, so let's talk about lesson 12.2. All right, or 12.1. So this is 13 on 12.1. All right, so find the x and y intercepts and the slope. We have a line here. And remember that our slope-intercept form of a line is y equals mx plus b. All right. So we got y equals negative x. So when I line this up in my head, all right, and I'm thinking to myself, how does this relate? I have y equals negative 1x plus 0. And remember, on the slope-intercept form, this is the slope. This is always the y-intercept. So we can read off the equation of the line two of these things. The slope of this thing is negative 1. And I'm going to show you why in a second, all right? And the y-intercept is 0. The real question is we still have to find the x-intercept, okay? So if I go to 2 pages here, so I put a graph into another page.
Wouldn't it be 0?
It will be 0. It will be, exactly, and I'm going to show you why. You got it. So if I put up a graph,
Well, I just did minus 0 divided by negative 1.
there we go. 2 ways to do it. One way to do it is to graph the line y equals negative x. And if I do it as a table, and again, you can check the math that I'm correct, you get this. All right? And you can see that it goes through the y-axis at 0, and it goes through the x-axis at 0. All right, so it is 0. And you just said the other thing. You had the realization. The other thing is we always know that if it's going to go through the x-axis, there's going to be an x-intercept, it goes through the x-axis when y equals 0. So you could fill that y equals negative x in. 0 equals negative x. Well, that's x equals 0, right on. And the y-intercept can be found the same way. Y equals negative x. For the y-intercept, you know x has to be 0. So you plug that in, you get y equals 0. All right? So that's problem 13.
Oh, and then you always put this over 1, right?
Yep, that's always over
So
1.
it's down and over.
Exactly. So this is over 1. That's okay. 1 over 1, and she right on. Down 1 over 1. The line got erased. Down 1 over 1. And again, this is a time, unlike distance, we look at the sign. You went down 1, so it's negative. To the right 1, it's positive. That's the slope of negative 1. So if I erase all this, or I go to a new page and back to a single page, and I look at the next one in the book, x equals 2 and y equals
15, yeah.
15 is x equals 2, and I'll skip 17 because it's almost the same. All right, again, this is a special case, and I always ask, can I pick 0, or can I pick x? And the answer here is no. I can't just pick x. X is always, so can I pick y? Yeah. And again, whoops.
That's simple.
That was a bad, yeah. Well, slope is hard on this, okay? The x-intercept is 2, right? That's where it intercepts. It intercepts, so the x-intercept, where does it hit the y-axis?
It doesn't.
It doesn't. So there is no y-intercept. Because it doesn't hit it ever. It's parallel. Now the slope is a little bit of a problem. We make the triangle. Well, the triangle is rise over run. I'll tell you right now, the rise I just did is 3, and the run is 0. Can you ever divide by 0? No, you can never divide by 0. So in this case, the slope is undefined. When you have a vertical line, the slope is undefined. All right? If we do the next one, we're going to skip, 17 is the same, but let's do 19. 19 said just graph, but let's do both, okay? As long as I'm going to tape it here. If I put up the graph, again, I can do this 2 ways. I'm going to do it this way. You can make a table. All right? Or, and you plot those points, you'll get it. Or you can look at this slope-intercept form. The intercept is 3, down 4 over 1, which is 0.1, negative 1. So again, if I'm identifying the slope can be identified immediately. It's negative 4 over 1. The slope is negative 4. The y-intercept can be identified immediately. It's positive 3. Now, here's a case where we can't identify the x-intercept from the graph. When I look at it here,
Oh wait, so that whatever it's plusing is the y-intercept.
in the y-intercept. The plus thing at the end is always the y-intercept. The x-intercept here can't be read graphically unless we make a lot better graph, and I won't do it. I'm lazy. So I'll go back to, I know this point is the x-intercept, x sub I comma 0, right? Y has to be 0. So if I plug that into this equation, I can say 0 equals negative 4 x sub I plus 3. Move 3 to the other side. Negative 3 equals negative 4 x sub I. Divide by negative 4 both sides. And I get that the x sub I in this case, the x-intercept right there is 3/4, 0.75.
Wow.
And we just did it. And I went pretty fast, but that's the graphing. And for problem 19 here, all you had to do is graph it.
Wait. Oh, you just replaced the x with the x sub I.
Yeah, just so we just, yep, I just subscript it.
I get it.
I just subscript the x sub I. It could have just been x.
Yep, I get it.
All right?
Makes sense.
And should we do one more that way, as long as we're cruising, before I shut her down? I will jump to 23, all right? Because again, 23 is a little more difficult.
Do I have to write these down since we did them in here?
All right? Again, first thing you always do if it's in this form is it needs to be in our standard form. So you have to solve for y. Always y, always y, always y. Did I say that enough times?
Yes.
Always y. All right. Divide by 25. And again, this is the algebra part that can slow us down. Mr. Anderson's been along.
2 over 5.
Yep, negative 2/5 over x plus 4. And I'm going to use the slope-intercept form. If you make a table, it'll work. You can make a table, pick negative 5, 0, and 5, and you will...
I don't get how where you start just at the 5, because the 5's
on the bottom, yep. The 5's the denominator, so I pick negative 5 and 5, and 0 always works. 0 is going to be 4. Negative 5 gives us 6. Positive 5 gives us 2. But I'll go back to the other method. Plus 4, that's the y-intercept.
Okay.
Boom. I just found the y-intercept. That's 4. Down 2 over 5. Back 5, up 2. Oh. And I butchered it. I'll make it bigger. There. There. Point is I can read the y-intercept. I can read the slope here. The slope is negative 2/5. But we're in a case again where the x-intercept, which you don't have to find for this problem, but since we're talking about it, we don't know. It's out here someplace. If I make
Can you find it?
if I make a better graph, yep, but we're going to find it using our equation. And again, when you have the x-intercept, y has to be 0. That's the relationship. So I take the equation, negative 2/5 x plus 4, plug in 0, and again, I'll change x to x sub I. So 0 equals negative 2/5 x sub I plus 4. Negative 4 on both sides, you get negative 2/5. Again, I will always, in this case, reciprocal. Negative 5/2. And much for that. X sub I, the intercept this time, positive 20, happens to be 10.
Good deal.
And there we go. And that is the homework.